Okay, this is a video recording of Lesson 9 titled Attributes, Reflection, DLLs, and Third-Party Libraries. And these topics could all stand on their own and be talked about separately in different lessons. But for the sake of Lesson 9, we're going to connect these topics together to not only kind of solve some problems that arose in Lesson 8, but then also to set the groundwork for Lesson 10, where we'll be using C# to analyze and process mass amounts of complex data. So these topics don't need to be connected together, but we are going to connect them together for the sake of cohesion. So where we left off on Lesson 8 is we had to modify our bank account class to first not have any parameters in its constructor. So we removed the parameters from the bank account class constructor, and we had to remove the private fields from our bank account class and instead turn them into public properties. And also we had to give all of our public properties a public get and a public set. And so what we did is we destroyed the encapsulation of the bank account class. Originally, Social Security number was a hidden piece of information, hidden in a private field encapsulated by the class, and balance in US dollars had a private set. Any outside code could see the balance in US dollars, but we wanted to control the modification of this data, so we gave it a private set, and we destroyed all that encapsulation here in Lesson 8. And we did that so that we could freely serialize using the JSON serializer our bank accounts to JSON text and store it in a data file, and then freely deserialize our bank account objects using the JSON deserializer to restore our object from this text. Okay, so that's why we did it, and this wasn't strictly necessary, but it was convenient. It was convenient. So we could have done it like this. We could have kept our bank account class exactly as is, so with our Social Security number as a private field, with our balance in US dollars having a private set. We could have kept it like this, but then look what happens when you have to serialize and deserialize. When you serialize, you have to add this method on your bank account class, and this method has to build a JSON object that creates these key value pairs, right? It kind of works like a Python dictionary. If you want to think about it like that, you create these key value pairs with the name of your data and the value you want to store with it, and then you return the result of that. So you have to add a serialize method to your bank account class, and then to deserialize, you're going to need to, again, create this intermediate object, this JSON node, and then pull out key value pairs, and then because you can't modify the value of balance in US dollars, you're going to have to call the deposit method in order to change that to what was saved in the file. So this is more complex, and I mean it requires you to duplicate the names of your properties in these hard-coded strings, and you have to do weird things in order to get your object back in the same state. So we have to call account.deposit to put that value back next time the program runs. Okay, so that's why we got rid of the encapsulation. And so we still have issues. Right? So in our data file, we could have bad data, right? Account holder name was not supposed to be empty. Social Security number was required, right? So formerly it was a parameter in our constructor, making sure we required that a bank account had one of them, and now now we're free to have bad data in our data file and not have the required information, or we have information but it's not in a valid format. And so when we deserialize, we're going to be creating bank accounts that are invalid. So we're going to solve this using the material from Lesson 9. Okay, so this is our updated tool graph here, so our tool diagram, and you can see the new things added are in Azure DevOps. We're going to be talking about this artifact section in Azure DevOps. We're going to be talking about DLLs here, and we're going to be talking about NuGet. And we'll be using NuGet, but we'll be using it through Visual Studio. So there's great integration between Visual Studio and NuGet. So that's how we'll be interfacing with NuGet. So that's the new kind of tools we'll be learning, and we'll also be learning new C# features. The first C# language feature we will introduce here are attributes. And attributes are metadata or tags that can be placed on properties, methods, classes, and so on that denote some expectation we have about that thing. Okay? So if we look here at our bank account class, I've added attributes, right? These little tags that sit directly above the properties, and they are describing an expectation we have about the data in these properties. So if we look at account holder name, we are saying that we expect the account holder name to not be null. Okay, so we had this not null attribute. And on top of that, we're also expecting that the account holder name is not the empty string, right? So we're describing that this is our expectation using these two attributes. And we do the same thing for social security number, but additionally we add this attribute that says we expect the social security number, the data in the social security number property, to follow the format of 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. We expect it to be in that format. So that's what this attribute is doing. Okay, and then on our social security last 4, we have this attribute for JSON ignore, and that is saying, hey, when we serialize, we don't have, when we serialize and when we deserialize, we don't have to worry about this property. Because this is a dependent property, the only thing it is a set of instructions to get us from data we already have into data we want to provide if someone was to call this property. Okay, so we use the JSON ignore attribute to describe that expectation about this property. Okay, so that's what they look like, and the important thing to realize is that they don't do anything by themselves. So other code will have to look at these attributes in order to inform what that code should do. So, for example, the JSON serializer is going to look at the object you're serializing or deserializing, and it's going to look and it's going to see if I see a JSON ignore attribute on a property, that means that when I serialize, I don't have to worry about this property. I don't have to put this this data in the JSON that I generate. So with the JSON ignore property on here, we get a result from the JSON serializer that looks like this. And without the JSON ignore property, we get the full result where we are still serializing the last 4 of the social, even though that's not necessary. Okay, so that's what attributes are for. And again, because they don't do anything, we kind of need to introduce a new idea here. So, okay, and that idea is reflection. So reflection is a mechanism that allows an object to reflect upon itself with regard to its class definition. Okay, that's a simplified description. The full details are in the documentation linked on this slide. But you can think about reflection just like you would maybe normally think about it. So just like you can reflect on your life or your work or your teaching style, whatever it is, your objects can too reflect and ask, hey, given what the programmer has put in my class definition, am I meeting the requirements that programmer described? So in particular, we want to think about attributes. So given the attributes that were placed on top of the properties in my class definition, do I as an object meet the requirements that are set forth by those attributes? Okay, so that's the general idea of what we are doing with reflection, and we're not going to go too deep into this idea. This kind of advanced C# here, so I just want to mention it just so you're aware. What we'll do instead is we will use a third-party library to do the reflection of our objects for us. To introduce third-party libraries and DLLs, I want us to think about how programmers might share code with each other. So one way we can share code is, of course, via copy-paste. So we can copy code from Stack Overflow and paste it into our code to solve some problem. Or we can go to Azure DevOps and to some Git repository, copy code from there, paste it in our code to use it in our solution. And the beauty of this is that you are able to read this code on Stack Overflow or in Azure DevOps, and you can learn from it, and you can also modify it or tailor it to meet the needs of your code. Okay, so that's the great part about copy-paste. The disadvantage of copy-paste is that it's not easily scalable. So if you want to leverage some really complex functionality in your code, it will become increasingly difficult to copy and paste all the code that makes up this complex functionality. So we need to do something else to handle this. So what we can do is reference libraries or binary files in our code to leverage that functionality. So let's talk a little bit about these binary files. So source code, our C# source code, is always compiled into machine code by a compiler before it is executed. So C# is human readable, right? We can read the source code, and to make it readable by a computer, your compiler needs to take it and convert it into ones and zeros, and the computer reads those ones and zeros. And so at the end of the day, any functionality we want to leverage can be represented in binary, and the binary can all be placed into one file that your computer looks at. Okay, so the idea here is we can package and condense all of our functionality into one of these binary files and call or access that binary file from our code in order to use the functionality. And of course, that's the advantage, and the disadvantage is that you can't read what's in these binary files, right? It's all ones and zeros, so it's not human readable. So those are our two options for sharing code, and we're talking about this one here on the right, referencing libraries. So in our case, in our world, these libraries come in the form of DLLs, okay? So dynamic link libraries. And again, they're files containing machine code, and you can reference this machine code from your C# code to access the functionality that exists within those DLLs. Okay, and well, we actually already have been doing this. We just haven't been mentioning that this is what we're doing. So every time we add using statements at the top of our C# file, we're saying, hey C#, we are using functionality that exists in a DLL that is somewhere else on the machine. So, and in our case, Visual Studio knows where all these DLLs are stored. So, for example, this using statement, so using system.text.json, Visual Studio added this using when we started using the JSON serializer. It added this using to the top of our C# file. And it also knows that if someone is using system.text.json, well, we're going to have to reference the code that makes up system.text.json that is in some DLL on the machine. So here, well, we can take the mystery out. We can see that when we use system.text.json, the Visual Studio is going to need to look into our machine, into our file system, and find where that code is located. Okay, so in here we see we got system.text.json.dll. Okay, so that's what the using statements are doing. And another thing to say is the code we write, so all the code we've written for these lessons and for your homework assignments, all of it is being converted into these DLL files before it is executed. So when you hit the play button in Visual Studio, that's what needs to happen is your C# is translated into this machine code and placed in a DLL. So here's our lesson 5 exercise here. And you can see our code is going to be located in this folder, lesson 5, exercise code, but our DLLs are going to be in a subfolder called bin debug net 7.0. And here you can see this is our code translated into machine code that's placed in this DLL. Okay, so when we run our code, we're going to be calling this DLL. Okay, so in theory, if I want to share complex functionality with you, I can write the code that makes up that complex functionality, and I can compile it so that it's all in a DLL file, and I should be able to just send you that DLL file, and you can reference that DLL file from your code to leverage that functionality. And so in theory, we can do that, and that does work, but in practice, it's better to share these DLLs with each other by using a package manager, okay? And so we will use a package manager to manage all our references to these third-party codes here. So before we talk about package managers, let's first define a package. So a package is a bundle, we'll call it a bundle, that contains one or more binary files or DLLs and some other metadata about that code. So the author of who wrote it, the date it was written, the version number of the code, the company it belongs to, the purpose of the code, and so on. So it's just a bunch of DLLs that are bundled together and associated with some metadata. Okay, so package manager. Package managers, I got this quote from somewhere. A package manager is a tool that automates the process of installing, upgrading, configuring, and removing computer programs for a computer in a consistent manner. Okay, so we really want to go through a package manager because as versions of DLLs change and as we have to reference more and more to access more and more third-party functionality, it's going to get messy. So we really want to go through the package manager. And in particular, we will use NuGet package manager, which is built into Visual Studio and makes it really easy to grab other people's code and use it in your own code. Okay, so we'll be using NuGet package manager, but most development environments have their own package managers that make sense for their environment. So Python has pip and as well as Anaconda. So those are some Python package managers. Java has Maven. Node.js or JavaScript has NPM. NPM stands for Nodes Package Manager. Nodes Package Manager. And then C#. There's only one package manager, and that's NuGet, and that is heavily endorsed by Microsoft. So we get it really creates for a nice environment for sharing code because it all goes through the same technology, NuGet, whereas Java has many different package managers, Python has many different package managers, Node.js has or JavaScript has different package managers, and because there's so many different tools you can use for managing your packages, it makes it more complicated. But in C#, the answer is NuGet. Okay. So let's talk more about NuGet. So NuGet is an underlying tool or technology used for getting packages from potentially different locations. So the main place that you'll get NuGet packages or third-party libraries is from NuGet.org. So NuGet.org is the public central repository for sharing code across the world, right? So anyone can go to NuGet.org to find the packages they want and reference those packages in their library. And so that's the main one. But you can also host private NuGet packages or kind of internal organizational facing NuGet packages. So, and you can host these in Azure DevOps. So in Azure DevOps, there's this artifacts section here. And in an Azure DevOps organization, you can add your own packages to share within your organization. And so that's well, we're going to use both of these here. We're going to use an artifact that I've placed in our Azure DevOps organization, and then we're also going to use a publicly available NuGet package just to illustrate this process. Okay, so that brings us to our first exercise. Okay, so for our first exercise, we will address the issue we talked about earlier with validating that our bank account objects are in a valid state before continuing our program. So to do this, we are going to leverage a third-party library that I have hosted on our Azure DevOps organization. So Lesson 9 has some starting code at this URL here. And here it is, and I've cloned it in Visual Studio. And the only difference between this version of the code and the Lesson 8 version of the code is that I've added these attributes on our class. Okay, so what we want to do is when we deserialize an object, we want to validate the account. We want to validate the account has acceptable data. Okay, we want to do something like that. And to do that, we're going to use the third-party library, and it's located here at this URL. Okay, so you can see in our public Azure DevOps organization, we have the artifacts section, and here we have this simple validation library, and we can click on it, and we can see, you know, who wrote the library and what version this library is on, and so on. Okay, so what we're mimicking here is if you write code at a company or some other organization, you can package it up, put it in a central location so that other people at your organization or company can use that code. Okay, so let's get to it then. The first thing I want to show is if we click on our project and click show in or open in File Explorer, we can click this. We can see these bin and object folders. Now these contain the code for when the program was translated into binary. Okay, so if we look in here, so bin debug net 7.0, we can see the DLL that makes up our code. And we can delete these here. We don't need these, right? So we can delete these, and we can show that when you click run, you'll see these folders get regenerated by the compiler and by Visual Studio, and our code, the compiled version of our code, shows again right here. Okay, so it's being regenerated. And what we're going to do now is we're going to add that reference to the library, and we're going to show this again. So to add the reference to the library, we have to go to Manage NuGet. So right-click on the project and click Manage NuGet Packages. And we have to tell Visual Studio, well, where do you want to get the NuGet packages for? So obviously, Visual Studio is going to be installed with getting NuGet packages from NuGet.org, right? So that's kind of the default configuration. But we can edit this and say, well, not only do I want to get packages from NuGet.org, but I also want to get it from some custom location. So we can go back to Azure DevOps and configure the ability to get NuGet packages from our Azure DevOps organization. And Azure DevOps is going to help us with this process. So if we click on Artifacts here and click Connect to Feed, and then what medium are we connecting the feed through? We're going to connect through Visual Studio, and it's going to show us, or really give us the instructions for how to connect to this artifact section in our this artifact section in our Azure DevOps organization. So we can copy the name here, paste it here in the name spot, and we can copy the source URL here. So copy that, and we can paste it here, and we'll click update, and now we've added a place to get NuGet packages in Visual Studio. So click OK, and what we'll do then is we'll switch to the package source to the one we just added, and we can browse right from Visual Studio. Now, for whatever reason, there's kind of these weird packages showing up. I don't know why that is, but what we can do is we can search for the one that we know we want. So the simple validation library. So we'll search for that, simple validation. And here, Visual Studio will find, I don't know what this one is. I don't know who wrote this or what that is. But here you can see the one that I wrote and provided through our Azure DevOps organization. And we can click Install here. Okay, it'll ask us to confirm, and then we click OK, and it's installed. And if we revisit here, and we run the program again, we'll see, oh, there it is. It added to our bin folder this DLL simple validation library. So you can see that through Visual Studio and through NuGet Package Manager, it's getting this DLL from our central repository and putting it where it needs to be so that our code can reference this. Okay, so now let's use this library. So to use this library, we can, we'll go here. So this library provides a class called the reflective validator. Yep, okay. So here's that using. So using the simple validation library, which we just saw the DLL for, we have this reflective validator class, and we can validate object properties using the reflective validator class. And what type of object are we validating, right? So we tell that in our angle bracket. So we're validating a bank account, and the specific bank account we have at hand is this one stored in the account variable. Okay, so if we hover over this, we can see that the reflective validator returns an object called a simple validation result. So simple validation result equals. Okay, and all this is going to do is say, does this object meet the requirements of these attributes that we've placed on it? Okay, so to see if this works, let's go. I'm going to open the data file of where this is stored. Okay, data file stored here. I'm going to open this. Okay, and right now this data is valid. So let's see what happens. Okay. Okay, it says all validations passed is valid and there's no errors. Okay, so oh my gosh. So to use this, we can do something like this. Okay, so this should do what we want. If the result is valid, then we do as we've done before. If it's not valid, we print out what's wrong with the object, and then we can just do an environment.exit. Okay. So let's see that over here. Get rid of this breakpoint here. Okay, so account for Grace Hopper retrieved. All right, and that makes sense. If we look at this file, we have this here. Okay, so now let's make this data invalid. Let's make this empty, and let's put some nonsense here. Okay, so no social security number on this saved bank account and no account holder name. So now when we rerun it, the simple validator will say it's not valid, and we'll print the message that save file is bad, and then it'll tell us the validations that failed. So account holder name containing null does not satisfy the required attribute validation attribute, and social security number containing the value off the grid does not satisfy the regular expression attribute validation attribute. Okay, so there it is. That's the whole exercise, just illustrating that we can get this reflective validator that's in the code that is in this package, and we can get it on our machine. We can get the DLL on our machine. So here we see it right here. NuGet put this in our bin folder for us, and now that it's on our machine, we can add the using up top using simple validation library, and then use this in our code for our benefit to help us solve a problem that we had. So that's the first exercise, and then we'll move on to the second exercise of lesson 9. Okay, so the goal of the second exercise with lesson 9 is to set the stage for lesson 10, where we are going to analyze a large data set using C#. But for lesson 9, our goal is to take real-world data and get that data in our C# program in the form of objects, because we can't analyze anything until we have objects. So to do that reading and loading of the data into our program, we're going to make use of some various tools. So one of the tools is going to be a third-party library called CSVHelper, which will help us load the data into our program. And then we're also going to use another tool here this class from CSV tool to help us with this process. So the end goal here is to take a real data set and get it into our program, and we'll worry about analyzing it next time. So the data set we're going to use is electric generation data from electric power plants across the United States. So this data is available on EIA.gov, the U.S. Energy Information Administration, and we're using this data because it's sufficiently real and sufficiently messy, and also I understand it. So for homework 3, you'll be using data that you take interest in, but because I'm presenting this lecture, I'm going to use data that I'm interested in. Okay, so we want to get the latest version of this data set, and we're just going to take it right from online and extract it here. Okay. And let's go ahead and open it up and take a look at it. Okay. So it's a big data set, and what we have here is power plants, and the company that manages the power plant, and the state the power plant's in, and the type of fuel that the power plant burns, and just all this information. And we'll think more carefully about what this information is next time. But we just want to get this data set, it's a big data set, in our program. Okay, so let's do that. So in the exercise, we're going to make some manual manipulations to make this go smoother. We could write our code in a way that we didn't have to manually manipulate it, which you'd probably want to do if you were routinely pulling this data set. But we're going to go ahead and make these manual manipulations. So we are going to remove all but the first tab. So let's do that. Wonder if can you do this? There we go. All right. Okay, so we've removed all but the first tab, and what else do we want to do? We want to remove the merged header. Okay, so merged header up here. We're going to take this. It's these first 5 rows. We're going to delete them. Okay. And what's next? We want to replace all cells that contain only a dot with nothing. Okay, yep. So that's going to ruin our fun if we have these cells that just have this dot in them, and that's going to cause us some issues. So I'm just going to replace those. So I want to find the dot, and I want to replace with nothing, and I want to make sure I'm matching on the entire cell contents. I don't want to replace all dots, just cells that are only a dot here. Okay, so we'll replace all. Okay, good. 65,904 replacements made. All right, so cleaned up the data in that way. And so one more thing. Okay, convert the data to a CSV format. Okay, so we'll do that then. And this, there are ways we could have, as I said, there are ways we could have done this without doing these manual transformations, but I'm going to do them to make things a little simpler. Okay, so I want to convert to a CSV file here, and I want to save. Okay, good. clean things up here. All right, good. So we have the CSV file. I'll open that back up. Good, and you'll see we lost all that Excel formatting when we converted to this. All right, so now what we want to do is we want to go to Visual Studio and we want to create a new project. And the library, so we want to use a third-party library to load in this data from the CSV file. And say we didn't know what library we wanted to use. If we just type in CSV here, NuGet.org, we'll find some options here. So in particular, the one we're going to use is CSVHelper. And we can see that over 132 million downloads. It was last updated 4 months ago. It's on version 30, and the description is a library for reading and writing CSV files, extremely fast, flexible, and easy to use, supports reading and writing of custom class objects. So we're going to use this one, and I'll go ahead and click on it, and it links to other information, and I'm going to open the project website. Okay, so we got that up, and Visual Studio finally loaded, so we want to create a new console app, and lesson 9, exercise 2. Okay. Okay, so we create the new project. And I'll set some things up here. So we'll take in the file we want to read in through the command line arguments as we did before. So I will click on the drop down arrow here, debug properties, open quote, paste in this, and then the name of the file. Okay, good. And then we'll do our check just as we did last time. Okay, good. And then, okay. So just as we did last time, we're passing the data file to our program, and we want to use CSVHelper to read it. So we'll right-click and we'll manage NuGet packages. And here we want the package source to be NuGet.org. We want to browse NuGet.org, and we want to find CSVHelper, click it, and then click install. Okay, while it's installing that, confirmation message here. Okay, accept the license, sounds good. Okay, so it installed that, and if I run the program, we will see that NuGet has managed the process of getting the CSVHelper DLL onto our machine so that our code can use it. Okay, so we have that all set up, and what we can do up top here is do a using CSV helper. Now, we can refer to the library to figure out how to use this. So getting started here. So I've used this before, so I'm kind of working quick here. So I'm just going to copy this here. This is our code, and we want to give the stream reader our data file. Okay. So what this does is it reads in the data file that's in CSV format, and it'll return to you records which can be in the form of any object that you define. Okay, so what we want to do is take this data and represent it with an object. Okay, so let's design that object. So I'm going to copy these first, like I don't know, maybe 100 rows, and I'm going to go to the other tool that was referenced here, class from CSV. Okay, and what we can do with this tool is we can paste in our data, and we can ask it to, I'm going to configure this a little bit. We can ask it to generate a class, a C# class, based off of the data it finds. And so I'll click generate, and here you see it creates this power plant class that has all the properties that match the column headers of our CSV. So I want to copy this and go back to Visual Studio, and we can add a class and add the power plant class. And here it is, right? So this is what it generated. Now, still a couple issues. So we'll see the word reserved here is placed twice. So there's maybe 2 columns with the header reserved. That might be why that happened. So we will remove one. And then the other issue, right? This is just a tool, and it can make mistakes. So if we look at our data. So here we have a field called total fuel consumption, electric fuel consumption, total fuel consumption, net generation, right? So these are all numerical fields, right? Numerical values. But because there's commas in it, or for whatever reason, you'll see that the tool, define these as strings, but really we want to define them as numerical values. So I'm going to change this, right? So you got to check the work of the tool and update our class here. It looks like I got year right though, as correctly classified that as an integer. And so now we have a class that represents a row of our data. And what we do with CSV helper is we say, read in this data and get the records. Okay, so we'll see if this works. And can't access file. Okay, so I'm going to close the file. Okay, it might have worked. So let's see. Oh. And we're going to do a to list here for reasons I'll explain later. Okay, good. As I expected, it was not going to work. So it doesn't like that the header names don't match the property names. So our headers have spaces in them, right? Plant ID, plant space ID, and when the tool translated the C# object, it had to remove those spaces. So we need to normalize the match between. It all matches by name, so we have to normalize the names to make this work. And so I've already figured out how to do that, and that's we're going to use this method down here that I pasted in the Word doc. So this is just a regular static method that kind of removes spaces and special characters from text in order to create a match on our property names. And so all we got to do now is in CSVHelper, we need to grab this part of the config, and we are writing a method that prepares the header for match. So okay. Okay, yeah, so don't worry too much about the syntax we're seeing here. Just understand what that's doing. And we can pass in this configuration to our CSV reader. Right, and I know to do this because I had time to read the documentation. So if it's kind of looking weird so far, that's to be expected because you haven't had time to review the documentation. Okay, so now we'll try again. We'll run it. And now we can see it successfully loaded in the data into our program. And we have a lot of stuff that's being represented as a string, even though it's numerical. So we'll want to update that by modifying our class, right? There's a lot of properties on this class, so it'll take a second to modify it. So I won't do that live, but we modified these few down here. And we can see when we hover over records, if we scroll down to those properties, wait, hold on. Net generation, yeah, so this one is one we changed. This is being represented numerically, which is going to be good when we go to analyze this. So that's it for the lesson 9 exercise. With lesson 10, we'll continue this. I'll clean it up a little bit to make sure we're representing our data accurately with our class. But just wanted to show how we could use these two tools to get data from the real world into our program and represent it as objects. Okay, so we use the CSV helper to read the CSV file and do the parsing of the data. And then we use this other tool to generate at least a starting point for our C# class that models the data in this file. Okay, so that's all we have to do for lesson 9.